Okay, let's solve systems of nonlinear equations. So this first one is actually the top half of a circle. I'll explain how I know that in a minute. And the second one is a line. So we're going to solve it using substitution. Since they both equal y, I'm going to set them equal to each other. So to undo the square root, I'm going to square both sides. So let's do that next. So I got rid of the square root by that. And now I'm going to have to FOIL the left-hand side. So go ahead and pause it and do that on your own. Now I have quadratics, and so to solve a quadratic, you want to bring everything to one side to set it equal to 0. So go ahead and pause it, do that now. And I can use the quadratic formula to solve this, but before I do that, I'm going to divide every term by 2, and then I'm going to plug it into the quadratic formula. So please pause the video and do that on your own. And while I was doing the quadratic formula, I realized this is a positive 28 and a positive 14. So double check your quadratic formula. And then I'm going to go ahead and simplify it a little further. Okay, so I went ahead and I simplified it all the way down to 4 plus or minus square root 2, which tells me this semicircle and this line intersect at 2 places, and these are the 2 x coordinates. So now I'm going to plug it into my second equation to find the y coordinate. You can plug it into either equation, but the second one is simpler, so I'm going to do that. So go ahead and pause the video and solve for y. Okay, so I plugged in 4 plus root 2 and got out 4 minus root 2. So this is one of my coordinate pairs. And then I plugged in 4 minus root 2 and got out 4 plus root 2. So this is my second coordinate pair. So those are the 2 spots that they intersect. Okay, so let's talk about the 2 graphs. Okay, so looking at the first equation, let's try and figure out what it is. So let's square both sides. So I get y squared is 36 minus x squared, and bring x squared to the other side, and you get x squared plus y squared equals 36. Now this is a circle of radius 6. Now let's just pretend I was going to work backwards. So I want to solve for y, and then I'm going to undo this, and so to undo this square, I'm going to square root both sides. So typically at this stage you would say plus or minus if you were working backwards. So if I started off with the circle and then I was isolating my y squared, I'd get this, and then I would take the square root and get plus or minus. Well, the plus is the top half of the circle and the minus is the bottom half of the circle. So we know that this first one is the top semicircle. And the second one is aligned with slope -1 and y-intercept 8. So let's go ahead and graph those two. Keep in mind the 2 points where it's going to intersect, so we can plot those 2 points as well. So I found the decimal approximations. Okay, here is my semicircle. It has a radius 6, so I scaled it by 2s to fit onto my graph paper. If you went by 1s and it went a little bit off, that's okay too. I plotted the point 5.4, 2.6, and I plotted 2.6, 5.4. That's just to help me get this nice curve. And since I knew it was going to be symmetric, I just used my symmetry points over here to help me get a good curve. So I know that these 2 points in quadrant 1 is where it's going to intersect with the line. So let's go ahead and plot the line now. And I graphed my line. I apologize, I do not have a straight edge to use on my computer, so I did the best I can. It has a y-intercept of 8 and a slope of -1, so I went down 2, right 2, down 2, right 2, down 2, right 2, down 2, right 2, and it intersects there at 8 as well. And I can see that it's clearly intersecting at those 2 points. Now if you were to graph this on your calculator, it wouldn't look like it was intersecting here. And that's just because of the inability for your calculator to do a good job. But you know that this is the top half of a semicircle, so graph it appropriately. Okay, let's move on to the next. Okay, so this first one is a line, and the second one, when I see a y squared and not an x squared, I see a y squared, I know I'm going to have to do a completing the square here, and it's going to be a sideways facing parabola. So I have a y squared here, so I know it's going to be sideways. If it was an x squared and just an x squared, then I would know it's an upward facing parabola. So let's go ahead and write this as in standard form. I ahead and solved for y for the first one so that we could see as a line. The second one, I said we're going to have to complete the square. So for the second one, we're going to add something to both sides. To complete the square, you can't have a coefficient in front of the y squared, so I'm good there. So it's going to be y minus, you take half of -2, which is -1, squared. And you take your -1 and you square it, and you add it to both sides. So I'm adding 1 to both sides. Now if I factored this right-hand side, it is a perfect square. It factors as y minus 1 quantity squared. And I'm just going to rearrange the terms, so it's x plus 1. So this is a perfect square. This is standard form for a sideways parabola, and you could graph it with a sideways parabola. You can say, well, it has its vertex, it went left 1, and it went up 1 for its vertex. So I know its vertex is going to be left 1, up 1, because you have your HK. Another way you can look at it is by solving, now that you've completed the square, it as a square root. So I'm going to take the square root of both sides, and I have plus or minus the square root of x plus 1 equals y minus 1. Or if I bring the 1 to the other side, it's y equals plus or minus the square root of x plus 1 plus 1. So now you can see it as a plus and a minus square root function that was shifted left 1 and up 1. And remember, the square root function has your key points, and it looks generally like this. So that would be the positive, and then the negative would be a reflection across your x-axis, and it would look like this. So you're going to go over 1, and then you're going to reflect it, and then if this was kind of like the origin, then you go 1, 2, 3, 4, and if you took the square root of 4, you'd get 2, and then you'd reflect it down as well. And so here is how you have your sideways parabola, or your plus or minus the square root function. Either way. Okay, so now we can graph our line. So our line is 1/2 x. So it has a y-intercept of 0, and you rise 1, run 2. Rise 1, run 2. It doesn't look like we're going to fit it onto this graph. So I have two options. I can either extend my graph paper, or I can rescale it. In your notes, you have a different graph paper than I do, so it'll fit naturally in your notes. So I'm just going to stick with ones because I think that'll be better for you. So I'm going to continue with that rescale, with extending my graph paper. Okay, so I drew out my line, and I went all the way out to 8, 4. But I do know that this is going to connect, and I don't know exactly where, so I'm going to draw this one out a little bit more. So here was kind of like before the shift. If you did 4, 2, the next nice number to take the square root of 9. So if you're at 4, then 5, 6, 7, 8, 9, and then it would go up there. So this one actually does intersect here at 8, 4, and then down here at the origin 0, 0. And we can confirm this by solving it algebraically. So to solve this one, we can go ahead and use substitution. Since they both already equal x, they equal each other. So let's set them equal to each other. Pause the video and do that. So again, I have a quadratic, so I'm going to set it equal to each other by subtracting 2y to the other side. There's only 2 terms, we can factor this. So I'm going to factor out the y, and I'm going to be left with y minus 4, and I have the product of two things equaling to 0, so I can use the zero product property to say y equals 0, and y minus 4 equals 0, or y equals 4. So I have my two y coordinates, so I can plug them in. You can plug it into either equation, but I'm going to plug it into the first one because it's easier to solve for the x coordinate. So if I start off with y equals 0, when I plug it into the first one, x equals 2 times 0, which is 0. So that gives me the point 0, 0. Then I can plug in y equals 4, and I have x equals 2 times 4, which is 8, and that's the point. My x is 8, my y is 4, 8, 4. So I see that it intersects at 2 spots, 0, 0, and 8, 4. I solved that using substitution. I verified that using my graphs. Of course, I can check this two ways. One is on my calculator, and two, the easy way is by plugging these two into both equations to make sure that it checks out. So word of warning, when you want to graph this in your calculator, you're going to have to plug in three equations. Your line, the upper half of this sideways parabola, or the positive square root, and then the negative square root down here, the negative square root. And that's how you're going to get a sideways parabola from your calculator. So the three things you plug in. Okay, let's move on. Okay, so this first one, I know it's a circle of radius 2, so I went ahead and graphed it. The second one, I have an x squared and a y squared. When you have an x squared and a y squared, for this unit, it's going to be a circle most likely. So what we need to do is complete the square to see what it looks like. So we have to complete the square here. The y is already a perfect square. To keep it, we're going to have our x's and our y's on one side and the constant on the other. So remember, when we complete the square, you take half of this number. So you're going to take, say, x plus 1 quantity squared. And I'm going to have to add 1 to both sides of the equation, because in order to make it a perfect square, you add 1 to both sides. So now this is a perfect square, and when I factor it, I get this. The y squared is already a perfect square. It's like y plus 0 squared. And so you combine that side, it equals 1. So now I have a circle of radius 1, but now the center has changed. So you have your HK, so the center is at minus 1, comma 0. So let's go ahead and graph that one. Okay, so I graphed my circle of radius 1 with the center at minus 1, 0. Now over here in quadrant 2 and in quadrant 3, I don't know really what it looks like, because it's kind of sloppily drawn because I didn't have a compass. So I know it's intersecting here at minus 2, comma 0. But does it intersect anywhere else over here? Not from my drawing, but maybe it does. So we're going to solve the system of equations in order to see where it does intersect. I had and wrote my two equations here, but what I did is I lined up my x squareds, my x, my y squareds, my equals, and my numbers, because I'm going to use elimination this time. And I want to eliminate a variable, and if I multiply my everything in my top row by minus 1, then I'm going to add straight down, and those get eliminated. And then I end up with 2x here. And my y squareds get eliminated. I'm left with negative 4, or x equals negative 2. And when I plug it into my first equation to find my y squared, you get x squared plus y squared equals 4, or negative 2 squared plus y squared equals 4. So you have 4 plus y squared is 4, or y squared equals 0, meaning y does equal 0. So it intersects at the point negative 2, comma 0, which I knew it did, and that's the only spot it intersects, so it needs to show that it's not intersecting anywhere else. So do the best you can in your pictures. So we can always algebraically check. So let's plug our point negative 2, 0 into both of our equations to see if it's true. So pause it and let's try that now. Okay, so I plugged my point into both my first and my second equation, and I get that it does in fact check out. So I know I solved it correct using elimination and graphically. Now to do it on your calculator, you can graph it and confirm. So circles are tricky because you have to do each semicircle separately. So you have to solve them all for y. So for example, you can solve this first equation for y, and you get y squared is negative x squared plus 4, or y equals plus or minus the square root of minus x plus 4. So one equation is the positive square root to get the semicircle, and the negative square root to get the other semicircle. The second circle we want to use where we completed the square, so I rewrote it here, and we're going to solve for y again. Okay, so I subtracted this x plus 1 squared to the other side, and I took the square root and I have plus or minus. So now I'm going to have plus the square root, and you can just type it in like that, you don't have to multiply it out, and minus the square root, which will give us the top half and the bottom half of the semicircle. Okay. To end this video, I'd like to offer you a pun, but I keep going in circles about my favorite one.